physiology of digestion and absorption, a very important part of the digestive system. Digestion breaks down the ingested food to their chemical building blocks, and in general we mean monosaccharides, small peptides, amino acids, and small fats or lipids. And those molecules are small enough that they can be absorbed across the walls of the small intestine. So digestion is that catabolic process that breaks macromolecules down into monomers that are small enough for absorption. Intrinsic and accessory gland enzymes are involved in that digestion. The actual chemical reaction is one that we looked at way back in the beginning when we talked about chemistry, but it is called hydrolysis. So water is added back to the chemical bonds. Remember, those monomers were made by dehydration synthesis, so the reverse of that would be hydrolysis. Absorption is the process of moving that substance from the lumen of the gut into the body. There are tight junctions that ensure most molecules have to pass through the epithelial cell rather than between them. Materials enter the cell through the apical membrane, the lumen side, and exit through the basolateral membrane on the blood side. Remember, there is a polarity to the cells in these membranes. Lipid molecules are not quite so easy to absorb. They can be absorbed passively through the membrane, but it's not that easy for them. Other polar molecules cannot cross the membrane on their own. They have to be absorbed by an active transport system. Most nutrients are absorbed from the chyme before it ever reaches the ileum. So how do we process those nutrients? Monosaccharides can be absorbed. Starch, disaccharides are broken down into starches, not disaccharides. Disaccharides are only 2 sugars, so that's not really right. But starches can be broken down into oligosaccharides and disaccharides. And that begins in the mouth, and one of the enzymes there is a salivary amylase. Those can be broken down into disaccharides. Those oligosaccharides can be broken down into disaccharides such as lactose, maltose, and sucrose. And then the final breakdown would be the disaccharides into monosaccharides, and that would include common ones: glucose, fructose, and galactose. Those are 6-carbon sugars. So starches within the diet are broken down by salivary amylase, and then further in the digestive system by pancreatic amylase. They're broken down into oligosaccharides or disaccharides. Disaccharides, common ones, would be lactose, maltose, and sucrose, and those would be broken down by brush border enzymes into monosaccharides such as fructose, glucose, and galactose. Pancreatic amylase breaks down starch and glycogen that didn't get caught by the salivary amylase into oligosaccharides and disaccharides. Then brush border enzymes, dextrinase, lactase, glucoamylase, maltase, and sucrase, break down those into disaccharides such as lactose, maltose, and sucrose, and then other brush border enzymes break them down into monosaccharides. Monosaccharides are co-transported across the apical membrane of absorptive epithelial cells using the secondary active transport with sodium. And then monosaccharides would exit across the basolateral membrane by facilitated diffusion. So pancreatic amylase breaks down starch and glycogen into oligosaccharides or disaccharides. Brush border enzymes break those oligosaccharides and disaccharides into monosaccharides. Those monosaccharides are absorbed on the apical surface, transported across the cell, and released on the basolateral surface. And then they make their way to the blood, where they are carried first to the liver through the hepatic portal circulation. People with lactose intolerance have a deficient amount of lactase, the enzyme that breaks down lactose, and cannot consume lactose. If you do eat lactose, it remains undigested, creates an osmotic gradient in the intestines that prevents water from being absorbed and that results in diarrhea. It can also pull water away from the interstitial space into the intestinal lumen. In addition to that, bacteria are going to metabolize the undigested solutes and produce large amounts of gas. That gives you the bloating, flatulence, and cramping pain. Treatment for this is to add an enzyme back to the diet, lactase, and that will help break down lactose where it is supposed to be broken down. Proteins. Protein is not only dietary, it includes digestive enzymes and proteins for the breakdown of mucosal cells. Proteins are broken down into large polypeptides, then small polypeptides and small peptides. They are finally broken down into amino acid monomers, although some of my research this summer has indicated to me that a lot of them are more easily absorbed as dipeptides and tripeptides and then broken down to amino acid monomers intracellularly before they are given to the bloodstream. So digestion begins in the stomach. Pepsinogen is converted to pepsin around pH 1.5 to 2.5, and it becomes inactive in the high pH of the duodenum. So proteins are broken down into large peptides into small peptides, polypeptides and peptides, and then amino acids, dipeptides and tripeptides on the outside of brush border cells. And my understanding is they get into the cells and are then broken down into individual amino acids. So pancreatic proteases such as trypsin and chymotrypsin cleave the proteins into smaller peptides. Carboxypeptidases take one amino acid off at a time from the carboxy end. Brush border enzymes also include aminopeptidases, which take off one amino acid from the amino end. Carboxypeptidases, or dipeptidases that break dipeptides into single amino acids. The amino acids are co-transported across the apical membrane of absorptive epithelial cells through a secondary active transport carrier involving either sodium or hydrogen ions. And the amino acids exit across the basolateral membrane through facilitated diffusion. So pancreatic proteases break them down. Acid in the stomach itself will break them down. Brush border enzymes will further break them down, transport them from the apical surface to the basolateral surface, in which case they will be facilitatively diffused through and picked up by the blood, transported again to the liver first through the hepatic portal circulation. Lipids are a little bit tougher. Lipids don't like to be in water, and our internal lumen of the gut is water. So one of the things that has to be done is they have to be emulsified. Triglycerides have to be treated with bile salts that allow them to dissolve in water. They are digested by pancreatic lipases that break down fat into monoglyceride and two free fatty acids. Fats do have a tendency to form micelles. Micelles are small, circular, almost bubbles of oil, and that helps when they are coated with bile salts and something else called lecithin. And then they can diffuse, leave the micelles and cross the epithelium membrane through diffusion. In the small intestines, we also get chylomicron formation, in which those lipid products are converted back into triglycerides, packaged with lecithin and lipoproteins, forming something called a chylomicron. And that chylomicron is then exocytosed from the basolateral side and enters not the circulation, but the lymphatic lacteal. And eventually that lymphatic fluid, lymph, we've called it before, empties into the blood at the thoracic duct, back into the venous circulation at the thoracic duct. Once it's in the blood, they are broken down into free fatty acids and glycerol by lipoprotein lipases so that they can be used by cells. Short-chain fatty acids can also diffuse directly into the blood. So we get emulsification with biosalts in the duodenum, breaking up large fat globules into smaller fat droplets, and that increases the surface area, which makes them available to lipase enzymes. And then pancreatic lipases will hydrolyze the triglycerides, giving us a monoglyceride and 2 free fatty acids. Those will form into micelles, which are consistent of those fatty acids, monoglycerides, bile salts, and lecithin. They take their components to the epithelial cells. They diffuse into the epithelial cells, and then the epithelial cells form them into chylomicrons, which diffuse out the basolateral side into the lymph, and they are transported as chylomicrons in the lymph. Nucleic acids, the nuclei of ingested cells in food contain DNA and RNA. There are pancreatic nucleases that hydrolyze nucleic acid to nucleotide monomers, and there are brush border enzymes called nucleosidases and phosphatases that break the nucleotides down into free nitrogen bases, pentose sugars, and phosphate ions. So they're not breaking them, they're breaking them down even smaller than the nucleic acid monomer. Those breakdown products are then actively transported by special carriers in the epithelium of villi cells. So nucleic acids are going to yield pentose sugars, nitrogen-containing bases, and phosphate ions. Vitamins. In the small intestine, fat-soluble vitamins A, D, E, and K are carried by micelles. They diffuse into the absorptive cells. Water-soluble vitamins C and B primarily are absorbed by diffusion or passive or active transporters. Vitamin B12, which is a large charged molecule, has to bind with intrinsic factor, and it will be absorbed by receptors in a process of endocytosis. In the large intestines, vitamin K and B from bacterial metabolism would also be absorbed. Electrolytes. Most ions are transported actively along the length of the small intestine. Iron and calcium are absorbed in the duodenum. Those are a couple of the exceptions to the rules. Sodium absorption is coupled with active absorption of glucose and amino acids. Chlorine is transported actively. Potassium diffuses in response to osmotic gradients. So if water is lost, if it doesn't work correctly, potassium will follow that water. And usually the amount in the intestines is the amount absorbed. We usually don't pass potassium. Iron and calcium absorption is going to be related to need. Ionic iron is stored in mucosal cells with a protein called ferritin, and when it is needed, it is sent to the blood where it's picked up by a different protein called transferrin. It allows to transport the ion. Calcium absorption is going to be regulated with vitamin D and parathyroid hormone. 9 liters of water, mostly from GI tract secretion, get into the small intestines. 95% of it is absorbed in the small intestines by osmosis. Most of the rest is absorbed in the large intestines. Net osmosis occurs if the concentration gradient is established by active transport of the solutes, and water uptake would be coupled to solute uptake for that reason. Malabsorption can be caused by anything that interferes with the delivery of bile or pancreatic juices, damaged intestinal mucosa from bacterial infections, or even some antibiotics. We also have gluten-sensitive enteropathy, or celiac disease, which is a more common malabsorptive disease in which there is an immune reaction to gluten, and gluten causes the immune cells to damage the intestinal villi and the brush border, and the treatment for that is the elimination of gluten from the diet. However, that is not as easy as it sounds. Gluten shows up in a large number of foodstuffs. Developmentally, we start out with a primitive gut. The epithelial lining is formed from endoderm, with the rest of the GI tract coming from mesoderm. The oral membrane becomes the mouth. It's formed when the foregut of the primitive gut fuses with the stomatum. Cloacal membrane will become the anus. It's formed when the hindgut fuses with the proctoduodenum. And by 5 weeks, the alimentary canal is continuous, a tube from mouth to anus. Shortly thereafter, the accessory glands will bud from the mucosa. And here we have it mapped out. And I again would ask you to check out figure 23.4 in your text. Cleft palate or cleft lip results when the palatine bones or the palatine process of the maxillae, or both, fail to fuse. It's dangerous because it makes the child unable to suck properly to get nutrition from mom. The tracheal esophageal fistula is an opening between the esophagus and the trachea. And cystic fibrosis, which we've talked about before in the respiratory system, is a genetic disease. Not only affects the respiratory system, it also affects the production of mucus, and that can block the pancreatic duct. After birth, fetal nutrition occurs, or before birth, fetal nutrition occurs through the placenta, but the GI tract is stimulated to mature by amniotic fluid being swallowed. Newborns have a rooting reflex that will help an infant find the nipple, and a suckling reflex that will help in swallowing. Newborns should double their weight in 6 months and then reach their adult diet by 2 years. Gastroenteritis is an inflammation of the GI tract. Cholecystitis are ulcers are problems generally associated with middle age. As we get older, the GI tract actively declines with age. It produces less digestive juices, the absorption becomes less efficient, peristalsis slows, and that gives you a decline in the frequency of bowel movements. Taste and smell become less acute. Periodontal disease can develop. Diverticulitis, fecal incontinence, and cancer of the GI tract are relatively common. Stomach and colon cancers are rare, even though those cells are Stomach and colon cancers rarely have early signs and symptoms. What I was going to say is small intestine cancers are rare, even though those cells are rapidly dividing. Metastasized colon cancers frequently cause secondary cancers, and they often go to the liver because a lot of the circulation from the digestive